So in this video, I want to help you a little bit with homework 10. But before we get to homework 10, I want to show you really quickly, if you hadn't already seen this, that right underneath the units, there is solutions to select textbook problems. And so when you go into this section, you'll see that there are solutions from 5.2, 5.3, 5.4, 5.5, 5.6. Select problems have solutions available to you online. So what you'd want to do is try the problems for yourself first, and then if you get stuck or after you think you've done it correctly, then you can come and find those problems in this section and you can see what a solution might look like. So it's all written down for you and you can take a closer look. Okay, back to MyOpenMath. So this problem set is worth 14 points, but there are only 4 questions. This is the shortest probably that you've ever seen, and that's because this is going to be a little different than the previous ones. Okay, so first of all, you're going to try to see if you can make the left-hand side equal to the right-hand side. So you would be doing some substitutions, right? You would replace cotangent with cosine over sine. You would replace cosecant with 1 over sine. You would try to combine these two expressions into one. So this is exactly what you would do here. So you would replace cotangent with cosine over sine. Then you would combine the cosine theta into cosine squared theta. See, they're going through every individual step. Then they seek to get a common denominator by multiplying sine theta by sine theta over sine theta, and that way it will end up with a sine theta denominator. Of course, that means that if you have a sine theta times sine theta, you end up with sine squared theta, but now we'll have a common denominator. Now when you combine sine squared theta plus cosine squared theta, that becomes 1. And as I had said earlier, you can replace this cosecant theta with 1 over sine, or you can just continue with the left-hand side and go all the way to cosecant theta is equal to cosecant theta. So you can verify for yourself that it is in fact an identity and select yes. For the next question, you are going to work out your proof on paper, and then you are going to make a picture of that, and you would actually upload it here. Now, if you have any problems uploading it to MyOpenMath, send me an email instead. Not a problem to put that in your email, or you can include it with your Blackboard submission of textbook problems. The important thing is that I receive your proof for this problem. This one right here, it's going to have you type up your answer. Now, typing up math can be pretty challenging. So what I would do is click on this corner button right here. When you click on the corner button, it should give you an expanded view. It's not behaving here. Come on. Oh, this is going to make it bigger for me here. Oh, okay. You can make it as big as you need it to be. If this is giving you problems and you don't want to type up your math, then you can alternatively do this one on paper as well. So if you would like to not type up your work, then you can send me a picture via email or through Blackboard. Blackboard's the best way to submit. But let's say I want to do this problem. I'm looking here at cosecant to the 4th minus cotangent to the 4th, and that is a difference of squares. So I might start with replacing this left-hand side. Ooh, I've got options. Okay, with cosecant squared of x plus cotangent squared of x, and then I'm going to multiply that by cosecant squared of x minus cotangent squared of x. That would be the difference of squares. So that's the left-hand side factored. And so now I want to come over here and see that since 1 plus cotangent squared is equal to cosecant squared, then cosecant squared minus cotangent squared is equal to 1. So I can replace cosecant squared minus cotangent squared with 1. So let me just copy this line. That's a nice thing. You can copy and paste. And then I'm going to replace this with 1. And then, of course, having replaced it with 1, my answer is now equal to simply cosecant squared x plus cotangent squared x, and that is the right-hand side. So this turned out to be a pretty simple problem, and it wasn't so bad to type up after all. But if you prefer not to type it up, you can handwrite your answer and submit it through Blackboard or email. Blackboard is always preferred to email. It's easier for me to grade through Blackboard. Now the difficult one. Question 4 is a challenging problem, and that's why I only gave you one of these types of problems. But you have to figure out how to do this proof one line at a time like this, okay? So the good thing is I can just walk you through what the answers are going to be, and I don't have to type it up. But if I see that I have two fractions and they have different denominators, then the natural thing for me to do would be to multiply this left fraction by 1 plus sine over 1 plus sine, and multiply the right fraction by 1 minus sine over 1 minus sine. And by doing so, I can then combine it into one fraction. So my new denominator is going to be 1 minus sine times 1 plus sine. And then you see that the numerator here did in fact get multiplied. Here, let me write this real quick. Okay, so I wrote out what I was talking about here. This first fraction needs to be multiplied by 1 plus sine x over 1 plus sine x, so that the denominator becomes 1 minus sine x times 1 plus sine x, and that's the denominator. And then you see here that this negative is right here, and then I have the cosine x here being multiplied to 1 plus sine x here. Similarly, right here, they would have inputted the 1 minus sine x over 1 minus sine x, and the result would be cosine x times 1 minus sine x, and then your common denominator. Alright, so then in the next line, what happens? Well, 1 minus sine x times 1 plus sine x is, of course, a difference of squares, and you can write it like this, or you can write it in the notation where the square is between the sine and the x, which is typically what we see. And then the negative, what's happening in the numerator? Well, when you distribute this, negative cosine x times 1 and cosine x times 1 are additive inverses, so they canceled out. Then we have negative cosine sine and negative cosine sine. So if you have two copies of negative cosine sine, then you have negative 2 cosine sine. So that's what happened there. Then in the very next step, we've used the Pythagorean identity to replace 1 minus sine squared x with cosine squared x. And then lastly, you have a cosine here, cancel with a cosine here. So you have just a sine x and a cosine x, and the 2 in the negative. And then the sine over the cosine becomes tangent. So there's a help video as well. But The reason there's only 4 questions to this online homework is that this is going to be pretty challenging to pull off, but we still need to work through these. And all my quizzes and tests are online, which means I have to use the problems in MyOpenMath for my quiz homework, for my quiz questions and my test questions, which means that these kind of questions are the type of questions that you would expect to see also on the quiz. Now, the quiz for 5.2 doesn't happen immediately because there are 2 5.2 homeworks. So you're going to see homework 10 and homework 11 consecutively with no quiz between them. And then once quiz 11 is done, then you could be ready for quiz 8. And so you will see that quiz 8 is going to cover all of 5.2 at once. And you're going to have a proof where you need to have a chosen file, a proof where you need to type up your answer, a proof where you need to fill in the blank, and that's it. So these 3 types of questions are going to be on the quiz. Alright, so that's it. If you have any questions, please let me know.